This is the 4.8 to 4.10 review. Calculators are not allowed. Number 2. This one is asking which of the following are antiderivatives of this function. So a quick and easy way to determine whether something is an antiderivative or not is to simply take the derivative to see if we end up with this little f. So this problem is going to require that you know your trig identities, and the one that you'll need for the test you also use in this review. So anything you don't use in the review you won't need on the test. If we look here, we want to take the derivative of this. So capital F prime will be a constant, which is 1/2. The next thing I hit is the power, so I'll do a 2 of the inside unchanged times the derivative of the inside. Simplify, and what do you know? It looks like sine of x times cosine of x, which is little f. So that means big F is an antiderivative of little f. So 1 works. Part 2 works the same way. In order for this to be an antiderivative of this one, when we take the derivative of capital F, we should get little f. So again, we will move through the constant of 1/2, then we'll hit the power, we'll leave the inside unchanged, and then we'll take the derivative of the inside. When we do this, we'll get a negative sine of x cosine of x, which is not the same as f of x. So 2 does not work. Roman numeral 3 is the one that tends to trip people up. If we look at this, we have a 1/4 that is negative. Then we hit the cosine, which will be a negative sine of the inside unchanged times the derivative of the inside. Well, at first glance, this does not look the same as this one up here, as little f, but if we bear in mind our trig identity for the sine of 2x, that's our double angle formula, then we can put all the constants together, which would be a positive 1/2, and then a sine of 2x is the same as a 2 sine of x cosine of x. So you can see that the 2's will cancel, and we end up with little f of x again. So Roman numeral 3 is also going to be an antiderivative.